Today's speaker is Dr. Rodrigues, joined the faculty as Assistant Professor of Wood Utilization and Biomaterials in the Department of Forestry and Environmental Conservation in April 2023. Dr. Rodrigues is originally from Brazil, where she pursued a bachelor's in forest engineering and master's and PhD in forest sciences with the Federal University of Espírito Santo, emphasizing forest products technology. Her passion for studying wood began when she looked at a wood specimen slide under the microscope for the first time. I think we've all done that. Dr. Rodrigues first came to the U.S. as a visiting student and worked closely with recognized USDA Forest Products Laboratory research engineers. Before accepting her position at Clemson University, she worked as a postdoctoral associate at the Department of Sustainable Byproducts at Mississippi State University. She has developed research in wood quality from forest plantations in Brazil and conducted research projects related to computer vision, wood identification, and non-destructive evaluation of wood in the U.S. Please join me in welcoming Dr. Wood.
Thank you, Casey, for the introduction, also for the invitation. I think it's a nice chance for me to kind of introduce myself to the students in the department. And like she mentioned, I'm originally from Brazil, and I first come to US in 2016 for a kind of exchanging program, and that's how I ended up here again. And then I moved to here last year. So I will start my presentation, and I'll tell a little bit more about my background, and then we're gonna talk today about Eucalyptus Physiological Disorder. So she also mentioned that I've been working with wood quality from forest plantation. That's why I decided to talk about this topic today, because I think it will be an interesting topic to share with you. So I'm going to talk a little bit about myself, and then we're going to go through the project, and then we're going to open for questions in the end. So during my educational background here during this time, I was able to do different things. Like I was an internship for a while in a company called Suzano, and that's why this project is related to that company. So that's really important for you when you are a student to make those connections, because sometimes it's gonna come something else later, and that came as a project for us there. There we go. And then during my master's, I was a temporary professor also in the same university there. And in Brazil, sometimes when a professor take a sabbatical year, or if they have a gap between a professor and then they need to hire another one, they call temporary professor. I was there for a semester when I was in my master's. And during my master's as well, I did an internship in Argentina where I learned a little bit about dendrochronology, which is really interesting area. And then during my PhD, as I told you before, I came to US for an exchanging program, and I worked with the USDA Forest Products Fellows up in Madison, Wisconsin. So I had my experience in the snow for the first time, and all this winter weather here. So when I was finishing my PhD, I became a temporary professor in a different university. And again, for a year and a half, I think, yeah, it wasn't in a year and a half. And after that, they offered me a postdoctoral fellowship there. And then we start the pandemic. So, and after we passed the pandemic there, I decided to move to US. It means I moved to US last year, and I worked for a year and 3 months at Mississippi State University in the Department of Sustainable Bioproducts there. And I had the chance to organize, and digitize part of the largest wood collection that we have. And then also work in a project called Computer Vision Wood Identification, which is really important project that help us to stop illegal logging, because it's a field deployable tool that you can bring to the to the field and be able to use that and control the illegal logging. It's a really interesting project. And 6 months ago, I started my position here at Clemson, and I've been enjoying a lot working in this department. And last Saturday, I had my first experience going American football game. And it was super nice to see how the campus and the city just changed for a day. And I was there with Mia and Joanne and Luca. It was really nice. And also over these 6 months, I took my first course, which is first products. And we had a chance was during the summer camp, and we had a chance to visit 8 companies. And I was telling my students that I was the most excited person because as I'm new in US and also in South Carolina, it was super important for me to have this feeling, this thermometer about the first product sector here, and also starting making connection with the industry folks, right? So I will try to make it a conversation instead of just me talking here. So what you guys can see from this plantation picture, what you can tell me about this plantation?
Monoculture.
Sorry?
Monoculture.
Monoculture. What else? Planted. What else?
No understory.
No understory. I like that because we have the life. Yeah, that's correct. What else?
Even aged.
Even age, plantation, and we can see a kind of homogeneity here, right? Comparing trees. So that's what we have as our high technology in first plantations in Brazil. So eucalyptus species started to be planted in Brazil 50 years ago. And then from that, we have designed a high technology that we can create hybrid species. We can combine species that grow fast with species that have a nice adaptability and sometimes have like a great quality for X products, other for Z products. And that's how our forest sector looks like right now. And based on that, we have around 10 million hectares covered by forest plantations in Brazil. And from this total, 75% is just eucalyptus. So it is a very important species for the sector there. And when we talk about eucalyptus in general, we call eucalyptus even the Coringa species, because the trade name is eucalyptus as well. So for that, we have in total over 600 species, and those species has a really range on wood density. We have species with low density, medium density, and high density. What that is important when we talk about wood? Why this big range of wood density it is important? Does anyone know why? Patricia.
Helps with the strength.
The strength and different types of woods, because so do you think that we need the same wood species or the same wood quality for construction that we need for pulping production? What do you think? No. So that's why eucalyptus is so interesting about it. You have species that are being used for producing panels, producing charcoal, producing lumber, and also producing pulp and paper. That's really interesting about these species. And when we talk about panels, it's not just OSB, but MDF as well, which stands for medium density fiberboard. That's being used a lot to this use as well. But eucalyptus became a major fiber source for pulp and paper companies there. That's how these genetic improvement came from the pulp and paper industry. And a lot of money that they have been investing over these 50 years. But even though we have all this technology and eucalyptus well established, well adapted in Brazil, and does anyone know where eucalyptus is native from?
Australia. Australia.
Australia, Tasmania, New Zealand, that area. So, and eucalyptus found in Brazil a great climate and soil features to be well adapted here. But even though we have all this great adaptability, now we are facing some problems related to climate change. And one of these diseases we call Eucalyptus Physiological Disorder is a abiotic disease, and it occurs in eucalyptus plantations located more near to the coast areas in Brazil. And here are some symptoms and damage that this disease causes when you go in the field and see it visually. So the first thing that we can see there is that this disease causes the loss of apical dominance. So the tree is growing, and then somehow the tree starts to facing this problem. The trees lost the apical dominance, and as a strategy, it starts to have this increased in lateral sprouts to be able to survive this condition. So, and using the energy that the tree should be used for growing, what happens? It reduces the growth, right? And then in some areas, we also find kind of these mini crankers, which is a deformation in the stem. And I think it's hard to see here, but it has sometimes exudates. You have a gum thing there that's produced by the tree. And I'm not gonna go to the physiological part here, but again, it's a strategy for the tree keeping surviving in this environment. And again, this is caused by low adaptability of certain eucalyptus cones. We have in Brazil right now, we can call plastic cones and specific cones. What does anyone know what is plastic and specific cones? Or have heard about it? So the plastic cones are when you select a cone, let's call cone A, and this cone A goes well in different regions. So in your nursery, you just need to produce one cone. This is the plastic one and goes in the average in all regions. And then they are now trying to produce the specific cones, which means you're gonna have a cone A for the area A, cone B for the area B, and they will have the highest volume production, the wood production in that areas. So, and then some cones were selected for that company for a long time ago, and these cones were perfect, success adapted, and then somehow that cone start to face this problem. So here, the picture is not in a great resolution, but I really like because it's a great example that you have the same cone, but the adaptability, I'm sorry, you have different cones and the adaptability is different here. So that's why we decided to study this, because we are having this problem there. And then we could see that it affects the growth, and of course it's gonna affect the wood production, the volume of wood, and but we don't know about the quality of this material. And again, when I told you about the range of density and the different use, It's the same for wood quality. When you talk about wood quality, say, I think this wood has a high quality. But for what? Always when you say, this wood has a high quality for something, you always need to add this definition to something. And here we're gonna talk about wood quality for pulping production. And when we talk about pulping production, one of the two main properties that we look in the wood is the physical, which is in this case the density, and the chemical properties. Because we're gonna take the tree, transform the tree in logs, we're gonna transform the logs in chip, and we're going to cook this wood to take the fibers apart and make paper. Okay, so we need to pay attention to these major properties and the pulping variables. And based on that, we designed two research questions. The first one is how those symptoms or how those damages caused by the EPD, the Eucalyptus Physiological Disorder, might affect the quality required for pulping production. And the second question is, if it does affect, how we could recommend the use of this material, because that wood's gonna be cutting down and we need to use that material. If the quality is affected, how are we gonna deal with this material when it gets to the company, right? And this is the general goal is to evaluate the effect of EPD on the wood quality for pulping. One of the challenges for this project was to find the right place to perform the analysis. And we were lucky that we found a stand, actually two stands near each other, where we were able to classify as lower EPD symptoms stand, and another one with higher EPD symptoms. And from that, we took all the measurements, the DB8. Does everybody knows what is DB8? I'm not talking just the forestry, but what's DB8?
Diameter at this height. Diameter at this height.
That's it, perfect. And then we measure the trees, we cut down the trees, and then we collect all the samples for this project. Can anyone guess how old is this foundation? Just guess.
15 years. 15?
15?
Height.
5?
Oh, true.
I told the eucalyptus is well adapted in Brazil. It grows very well there. This is 3.5 years old. Wow. It is unbelievable, I know, even though it's facing a problem right there, the pathological disorder. So what we did was to take these materials from the lower and from the higher EPD symptoms and analyze them. And after that, what we did was to take a wood mix. We made a composition with different wood chips that we took from the company. We took for the industry and moved it to the lab of the company there to do those analyses there. And then after that, we mixed these reference materials with 20% of the higher EPD, the problematic wood, let's call it that. And then we compared to 80% of the same material. I'm not gonna go too much in this analysis, but we analyzed the chemistry of the wood and the density. For the chemistry, we analyzed the extractives, the lignin, and the pentosans. The pentosans are just the carbohydrates of the wood. It is the part that we need to make the paper. It's the most important part. The extractive is gonna be taken away, the lignin is gonna be taken away during this cooking process, and really we want we really want just the carbohydrates. It means the pentogens here. And here we have the cooking variables. And like I told you, plus the physical analysis, which is the wood density. And again, we took that two treatments and we compared them. What we could see here was that the density wasn't affected by the Eucalyptus Physiological Disorder, which is really good, right? So even though it's facing that, the density wasn't affected. However, the chemistry was affected and badly, because from here you can see there was big difference. It might not be big, looking like you guys looking here, but when you talk about tons of wood chips in a high production, that's gonna be terrible there for the company. And that directly affects the cooking variables. And here we can see that this is the most important number here, the screened yield. After all the cooking process, we took out the lignin, the extractives, and then we use more, even though I don't want to say that it wasn't different, but it was a harsher cooking here, and we use more alkali to cook this wood, and it affects directly the yield of the cellulose here, the pulping. And then, like I told you before, we took a reference treatment, we took the wood chips from the company. We compared them to those dosages here. And then we could see that when we use 100%, which is the highest dosage, we affect it negatively. So you can see here that the screened yield was the lowest here, and then we were able to give them a direction in how to use this problematic wood when they need to cut the stands and move this material to the company, because they don't want to lose money. And even though this wood has lower quality, they will lose the wood anyway, because they made a big investment planting those areas, taking care, and then they need that wood, right? As a conclusion, the results show that EPD symptoms, like I told you, not influence the wood density and the carbohydrates, but affected negatively the extractives and the lignin contents. And when we talk again, for pulp production, we don't want high levels of the extractives and lignin. That's a problem, right? Overall, the wood chemical composition from trees with higher EPD symptoms affected directly the cooking process variables. And how old was the trees? 3.5. That's normally we cut trees for pulping production between 5 and 7 years in Brazil. That would depend on the site index. Some regions we cut with 5, other areas we need to wait until 7. And then we could recommend to the company the use of the material until use less than 20% of the material to not be so effective when we talk about the yield and the cellulose production. Okay, as a scientist, we always keep asking ourselves questions. So in some areas, this problem, the trees can die if depending of the level. We're talking about levels of symptoms. In some areas, the level is so high that the trees die. You can do nothing with that. But in that area, we decided to return there and see if the trees were able to kind of recover from this problem. So, and then we decided to go back. How old do you think that this plantation was? It was close. 4.7 years old. Almost 1 and 3 months later, we decided to go back to the same area, same stands, and collect trees again. So even though visually it looks like the trees has recovered, the volume is still lower in the area was higher affected by the trees. But how about the wood quality? So we collect trees again, and we did the same analysis for that. We did the density and the extractives and lignin. So the wood density here slightly increased, and with the slight increase of the density, we got the extractives increase as well. And the lignin wasn't different from that. And the pentosone wasn't different as well. And the cooking showed us no difference between the stand, let's call A and B, right? So it is really interesting. I really like this project because we could see it in a practical way, how you need to make decisions. Let's see that stand on the right wasn't able to survive anymore. What do you might recommend to the company? Cut the trees right now because it can get worse, right? And the problem can increase. But we decided to wait, and then we went there, and the trees looks like it's recovered. I didn't keep watching that stand because I need to defend my dissertation and move forward, but the company might take care of that in that time. So it was a really interesting project that I think will be nice to present here today. And even though, like I told you, the stand seems to be visually recovered, the volume of wood was lower in the right side, the higher EPG symptoms. And this is a very special thing that the company needs to keep in mind because it is a risk. And nowadays we're talking about climate change. And I'm not familiar yet here in the US, but I believe we are facing disturbance here as well in some areas. But how we need to be prepared for that, for the future, okay? For them, it is important to create a strategy for the tree improvement program and consider selecting just ones that are tolerant to these climate change. And now they are really investing a lot of money on that, doing a lot of research in areas that are facing a drought there, because it is a huge condition, and the company owns the land there. It is different from US, where we need to procure wood for the company there. The company owns the land, so they need really to select ones that are well adapted to these climate conditions. And as a takeaways here, when we talk about wood production and Eucalyptus Physiological Disorder, what happened about the wood production? Talk, Jane, talk.
It's decreased.
It's decreased. What else?
Took longer to make the same amount of wood.
Sorry?
It was a more extensive cooking process.
Yeah, and when we talk about wood quality, right? So when we talk about wood production, we see that the growth is reducing, and the company has a high risk of that investment because it's something that they don't predict it. And when we talk about wood quality, the density, it is important, but is determinant when we talk about the chemistry of the wood, okay? So the chemistry here was very important for us to understand the application of the wood affected by this physiological disorder, affecting the pulping process, I didn't bring here today, but we did the bleaching and we also made the paper sheets there and we test them. And it was even worse when you go to the bleaching process and testing the paper sheets, because if you have a rusher process, you're gonna affect a lot of the fibers required to make the paper, and the paper is gonna have less strength because of these high chemical process. So the big challenges here for us was to dosage the wood chips higher affected by EPD, and the company were trying to predict the risk of those cones, but it's too many variables. It is hard to predict. It is complicated. That cone is not gonna be planted anymore, but if any other clone faces the same problem, it is hard to predict, especially because the clones it's already planted, right? And like I told you, they were looking for plasticity clones, for clones that have more this plasticity to be well adapted, even though it's not producing in the highest way, but it is still in the average. It's a lower risk for the company, and that's a different challenge for them there. And as a perspectives, they are using clones that has higher lignotubers, like has a higher quantity of lignotubers, and using molecular markers to select clones that are resistant to this abiotic stress here. And they can do it in an early stage. Early stage for us is not a big problem because we cut trees for coping with 5-7 years, but as soon as possible, if you're able to make the decision, better is and you save money, right? And other perspectives is to increase the genotype environmental studies there. They are kind of trying to cover as much land as possible to see where the clones will be adapted there and not facing these problems. So this is the paper that we published last year. Another one is coming. And if you are interested about the wood utilization and how this practical example affects the quality and the industry, this is a good example for you to check in. And before I wrap up, I would like to thank the institutions and the company and the co-authors of this publication, this project. They are from the Federal University of Espírito Santo, Brazil, and from the research center of that company, it's called Suzano. So with that, thank you, and I will take any questions.
You said that EPD is an abiotic disorder caused by climate change. I'm wondering, like, does it have to do with the amount of carbon in the air, or like what exactly is the?
That's the 1 million question,
Okay.
because they were speculating that some areas were because the precipitation has changed, and also because of the type of soil existed in that area, plus all the other climate variables. It's a kind of everything together. It's causing that, and they cannot say it's because of the soil, it's because of the precipitation, or it's because of the high temperature. It is a combination of conditions there.
You see a big change in them moving to more pinus species, or are they still sticking with eucalyptus? You said it like 25%, but because of this, is it changing because pine might be safer, or is it not that big of a deal yet?
That is not because of the wood utilization. We are the largest hardwood it means short fiber producer in the world. So that's not gonna change for pine trees because pine tree has a different market. So you use pine as a long fiber for packaging, for other purpose, not for like, because they also use this type of cellulose to make what they call chemical cellulose is the one that we use for screens, for making capsules for medicines. Sometimes what else? They use nano cellulose. Is that type of fiber that they used to use that in Brazil? I mean, in Brazil, not here in US, right? Yeah, but I don't see that movement to the pine, especially because the pine trees, we do have tropical pines in Brazil, but they are more, even though they are tropical, they are more in the south area of Brazil, which is more cold. And eucalyptus, it's already well adapted to southeast, central, and north of Brazil. We have also eucalyptus in Amazon area here. Yeah, it's not gonna change. Yes.
Yeah, as a fast growing species, like Eucalyptus is known to have some like side effect like high transpiration rate and other like high amount of water consumption. And I'm also very surprised that you have like 75% of eucalyptus plantation in Brazil. So do you encounter any kind of like problems when it comes to eucalyptus for having a large amount of them?
You talk about the evaporation itself, or?
I mean, like, this is just an example of it. Since you have like a large amount of eucalyptus, like 75% of the country, so do you have?
It's not 75% of the country.
Yeah, 75% of the
10
forest.
10 million hectares.
Yeah. So I mean, do you encounter like any other like problems with eucalyptus?
Any other type of problems?
Like what? Like water consumption problem?
Oh, that's something that, yeah. I don't want to go to that topic, but the people used to say that eucalypts dry the soil, and but all the trees, all the plants need water, right? But when we compare, for example, eucalypts and sugarcane, the sugarcane consume, I don't know, 3 times of water comparing to eucalypts there. And the good thing about eucalypts that we don't need these wet areas to grow them. We are moving all the plants now to the drier areas in Brazil because those drier areas not being used, you know. So that's a big discussion about eucalyptus and water. And yeah, I don't believe in that. It's not I don't believe the scientists say that this doesn't affect that badly, like the people used to say. What the point is a monoculture. And when you have a monoculture, we don't have that diversity that you expect. And then they find ways to fight with these monocultures in Brazil and say that's bad for water is one of the things. I don't want to explain anymore. I take more than I would on that topic.
Yeah, I was just curious, when you're talking about the plastic clones and the specific clones, like what's the scale of how specific? Are there like 10 different specific clones that are all across Brazil, or is it like every company has their own 500 specific clones?
Yeah, it is like that. And for the biggest one, sometimes they have more than 100 clones selected, but they manage it according to each area they will plant. And they keep in the nursery just the ones that they are producing for that time. And then they select different ones and they put new nursery there. And then they start to make new clones. I mean, new seedlings. But it is huge. Yeah, it is huge. I wish I could have pictures right here to show, but it's it is huge, and I'm really passionate about this technology, because here, when you talk about pine trees, the tree improvement is based on the seeds. There we use clones, so we clone based on the buds. We take the buds and then all the clones quickly, and it grows fast. They use some hormones, correct me? Yes, to induce the roots, and that makes the tree grow even faster. It is really interesting, the nursery technology.
Are they gonna be playing with the density? As far as like, because those are really dense stands. Will they like try to open it up a little bit more to see if they're gonna grow better?
For pulping now,
Eucalyptus? Yeah.
that's a big difference, and I'm learning here how to grow trees in US, because there we plant the stand for pulping, we plant the stand for charcoal, we plant another stand for timber. Of course, for timber, you're gonna thin 2-3 times to have space for tree to grow. But when you talk about pulping, you're not gonna thin,
That really.
just keep right there, 7 years, clear cut, and then gonna come another one, clear cut. It's like a corn field or whatever crop production. Yes.
So when you went back to the site that had like visible recovery, do you know what contributed to that visible recovery?
We, like I told you, we didn't went to that far, because our goal was based the quality of the wood, but maybe some change on the precipitation, and it might have effect, or maybe the trees just face that problem in one season, and then it doesn't face anymore, and then they try to recover. Those are just speculations, right? Yes.
So I wanted to ask about,
Sorry.
I wanted to ask about like, are there any innovative new wood treatment methods to improve the wood chemistry after EPD? Like other countries might be adapting that and not in Brazil, wood treatment methods.
To, like, you mean after you cut down the tree and use the wood before you go to the pulping
Yeah.
process
Yeah.
itself?
Yeah.
I would say that we do have some pre-treatments that we use there, but that wasn't the point, of this project. Yeah, they do have technologies to pre-treat the wood before go to the big digesters to cook. But yeah, that wasn't for this project, yeah, but not for EPD exactly, just in general. I don't know if I answered you.
You have like many, like you said, abiotic disorder, do you have many like biotic diseases and insect problems there? And does it like, if trees are stressed out by this disorder, does it make them more, like those problems more, an issue?
Yeah, I had a colleague that we were in the grad school almost in the same time, and she was working on the biotic disease, and she worked with a type of butterfly. And for eucalyptus, it is a big problem there, the butterfly, and they are trying now to kind of control using a different it is a biological control. I'm not gonna remember the name of the insect, I'm sorry, but we do face these problems there, and also fungi problems, yeah. We have bugs and I would say butterflies and fungi problems, like everywhere. Great, I love the questions.
All right, let's thank Briella for You're welcome to stay after and talk for more or Oh, there's a, yes. There's one that's called the- Yeah.
Yeah, yeah.
Some chips.
Yeah.